I'm just trying today to answer your questions that you had for some of the assignments in sections 8.1 to 8.3. So in section 8.1, for assignment number 65, the first group of questions that was asked was questions 69 through 77. Now these are all calculator decimal approximations, so let me just go through a couple of examples. So for example, to find the square root, like if you're going to find the square root of 9483, you use your calculator and you push the buttons so that you're doing square root. Square root is right here. Oops, there's from my other class. Square root. And then you just put the numbers in. 9483. And then round to the appropriate place value. This one they said to round to 3 decimal places. So you would do 97.381. on that one. Another one that they asked you for was cube root. We had the cube root of 423 was one of them. And to do cube root on this particular calculator, you need to go into the math section. And there's a cube root is right here at option 4. So you'd put in the number 423. And hit enter, and 7.507 for that to 3 decimal places. And then there was one that was the fourth root, which is an interesting thing. Well, if you're doing the fourth root of 100, they wanted. All right, so the fourth root of 100, in order to do that, you have to actually say, I want the fourth, and then you have to put the root. Here's a 5 of 100. And what that does is it replaces the little x that's showing in the index in the fourth root spot. With the 84 calculators, it does it even a little bit more elegantly so that the little 4 goes into the index spot, I believe. So 3.1623. Now if you want to find out that did I get it right, if you just hit the caret key, it takes the last answer, and if I took that to the 4th power, that checks and it does come back to 100. So you're able to do it and check it. So that was basically all you need to do from number 69 to 77. And then I will get right on those next questions. Actually, the next questions that were listed for this one, I'm looking in section 8.1. I think that the person made an error because it said questions 89, 91, and 95. And since there are no 89, it stops on that section at 81. So simply based on that, I think I'm going to have to just not really know exactly what questions were being asked unless it's meant to be in the next assignment. So we'll take a look at those. So we'll take a look in just a minute at the next section. All right, so moving along to 66, we're going to work our way through these problems. First thing we need to do is write them with fraction exponents. Now this was, the first couple I'm going to do here were one person's question, and then there was some overlap. So let's just take a look here. This is x to the 3/5 power, exponent index. This is x to the 1/4 power. In order to put it together, you need to have your exponents having common denominators. So 20. So this is 15/20. 'cause I had, not 15, sorry. 12. 5 times 4 is 20. 3 times 4 is 12. This is x to the 5/20ths. Then you add your exponents together because they have like bases, x to the 17/20ths power. But then they wanted your final answer to be as a radical. So this is kind of a strange one because it's got a 20 as an index and x to the 17th power. So we would have that. All right, so now we can move on to this one. Let's write our exponents as fractions. X to the 5/2 over x to the 8/2. Yes, I could reduce 8/2 to 2, but I want to keep it with common denominators because that's helpful. And it's easy to see that there's a bigger exponent in the denominator than the numerator. So when I subtract exponents, my x is going to be down here, and I'll have 8/2 minus 5/2. And that will give me 1 over x to the 3/2 power. And once again, they want us to write it in a square root. They want us to write it in terms of the square root or the cube root or whatever, the radical form. This one is a very interesting problem though, because when I do the square root of x to the 3rd, that can actually be simplified, and then we've got a nasty little radical in the denominator to deal with. So we've got some fun happening here. So when I simplify this one, it's x times the square root of x, because 3 divided by 2 gives you 1 outside with a leftover 1 inside. But then you can't have a radical in the denominator at the end, so I have to do this, which is fun. And this gives me x in the square root of x in the numerator, and then the denominator I get an x times another x. So your fully simplified form for this one is a square root of x over x squared. That one has those little tricks in it, so just be careful on that. When you've got fractions, there's sometimes some hidden things. Then we have this number 95. It's got a whole bunch of things happening. In the very inner heart of it, we have m to the 1/3 power. I don't know if you can see that 3 there, but there's a 3 as an index. But then we've got the 4th root of that. So here's my 4th root of m to the 1/3 power. Multiply the exponents. So you have m to the 1/12 power. And there was a couple people with this question, so this one's kind of not too terrible. So it's the 12th root of m is your final answer for that one. All right. This one does that all with attitude because in the inside we have y to the 1/2 power. All of that is to the 1/5 power. All of that is to the 1/3 power. So it's a matter of multiplying the exponents out. So this becomes y to the 1/10 power to the 1/3 power, which equals y to the 1/30th power, which equals the 30th root of y. Okay, so these are actually kind of fun and benign. This one gets pretty tricky, so be careful on it. And then let's take a look at assignment 67. Just give me a minute. All right, and your questions to numbers assignment 67. If you're going to simplify this, you need to first think about the number part. 50 does factor, so I'm going to factor that down. 25 and 2, which is a 5 and a 5. Since there's a pair of 5s, a 5 comes out. and your 2 is left in because there isn't enough to square root. Here we get the square root of 25, which gives you 5, but the 2 is left over. There are 3 x's here. You're looking for pairs of x's because the square root of x squared is actually x. So we take our exponent divided by our index. This tells me that I have 1 x that comes out and I have 1 x that stays in. They did give a little disclaimer on this problem that that all of the variables are positive, so we don't have to worry about that square root technicality at all. So here would be this one. This one, square root 13. 13 is unfactorable, so our square root, we're definitely going to have a 13 left in here. We're going to use this exponent divided by index rule. So for x's, 7 divided by 2 gives you 3. So 3 x's come out. And 1 is your remainder. You have 1 remaining inside. Y to the 8th power, exponent divided by index gives me 4 y's that come out. And since there's no remainder, we just end there. So there's this answer. Here's this answer. And then over here, this one's kind of, you need to get the same, denominator in your fraction. I'm going to write this as 4 to the 1/3 power. And I'm going to write this as 3 to the 1/2 power. Now, an interesting thing with this one is here, this is really a 2 squared. So I want to rewrite this as 2 squared to the 1/3 power. And this is 3 to the 1/2 power. So this is really 2 to the 2/3 power. And this is 3 to the 1/2 power. The directions say writing the radicals with the same index. So in order to get the same index, we need to get a common denominator here, even though the numbers are different. So this is, if we want a common denominator, I'm looking for 6 as my common denominator. So this one is 4/6, and this one is 3/6. So they want us to do it with the radical method. So this means that I have the 6th root of 2 to the 4th times the 6th root of 3 to the 3rd, which means that I have the 6th root of 2 to the 4th times 3 to the 3rd, which if we do this out the long way, 2 times 2, 4, times 2, 8, times 2, 16. This is the 6th root of 16 times 3 times 3, 9 times 3, 27. So we're getting the 6th root of 16 times 27. I'm going to just go right here, 16 times 27, 432. So in order to simplify this one, we need to write the radicals, have the common denominators, and just go from there. Now, another question someone had asked was on the lesson from April 28th to go over the last 2 parts that had rational exponents. So let me take a look at that and I'll be right back with you. All right, and backtracking to this, let me just see if I can make this a little bit clearer. If you have anything where you've got all products in it and it's to a power, the best thing to do is to take the exponent that's on the outside and bring it into everything that's in there. It's kind of like a distributive property, and that's what we did with that. So negative 2/3 times 4 was negative 8/3, and so on and so forth until you bring all of these in. Then we want to have positive, we don't want these negatives hanging out here. So in order to make positive exponents, if you remember from way back in the when we had just regular integers up here, you had to jump it over the fraction bar. So that ended up bringing this 8/3 down, and it brings this 2/9 came from here to go up. Then our rule is when you have like bases, you add the exponents. So we can do that, but then finally you need to actually reduce your fraction at the end. That makes it easier. This one you've got to be careful with because it's not a power to a power. So when you distribute here, you are multiplying this times this, which means like bases add exponents. So you've just got to be careful with that. The question was asked of the last two, so I don't know whether it was the last two slides or the last two questions. So here are these. These actually are almost identical to the questions that I just went over with the homework, and I think that that person had that same question. So I'm hoping that going over the ones that we had in the assignment actually just re-went over this, okay? Because this is really just this back here, I believe. Oh no, not that one. It is the other one that we went over. These. Okay? So hopefully that one now makes more sense to you because these are really the same question. So we've hit everything that I've gotten as far as questions answered. I hope that this is helpful and that you're doing a great job on your quiz. Have a great, blessed day.